Okay, so today we are going to be working on multiplying decimals using the area model. Now, multiplying decimals is new to us, but the area model is not new. It may be a little confusing, so I just want to remind you of what the area model looks like and how we can use it for a problem like this. So, really quickly, the area model. First of all, what is area? Okay, so area, remember, is the space inside of a figure, a closed figure. And in our case, we're working with squares right now, but this also works for rectangles. And the formula for area is length times width. Length times width, right? So given that the area is length times width, we know that the product of these two will give us the number of squares in the middle, inside. Let's do a quick example. So what if I had the problem 2 times 3? Really easy. I'll say that 2 is the length and 3 is the width. So 2 indicates the 2 squares this direction, and the 3 is the width, the vertical squares. Okay, now in order to use the area model to find the product, we will simply shade in the 2 squares going up and down and the 3 squares going left to right. Let me just show you because it kind of sounds confusing. So, here are the 2 squares that indicate the length. And here's the 1, 2, 3 squares indicating the width. All right. Now I shade everything in to make it really clear. The overlapping area, right here, is the product of 2 times 3. In other words, these 2 squares are appearing 1, 2, 3 times. Altogether, how many squares do we have? 2, 4, 6. Our area, or our product, is 6. And this is a really simple problem. Let's check it. 2 times 3, we know. 6, right? Mental check. So clearly we can use this area model to help us multiply. Now with a problem like this, we don't have to. You know, we definitely did that first, second, third grade. We don't need to do that now, we're a little bit older. But it is really helpful when we start to move into things like decimals, when we're not just working with whole numbers. So let's try a problem together that's a little bit harder. This next one will be 4 times 3.5. All right, so as I look at this problem, I'm thinking to myself, 4 holes. Very easy, right? 4 squares. I can easily draw those in. The next one is 3.5. That's where it's a little bit trickier because a half is the decimal, right? Something less than 1 whole. But I can still shade in a half a square. That's not a problem. So let's try this. Length times width. So I'll be going 4 squares across the top. 1, 2, 3, 4. And I'll be going 3.5 squares vertically or down. 1, 2, 3.5. So for this one, I'm going to make sure that I draw a new line in to indicate half of a square. All right, and remember that I'm shading in this whole area, making sure to shade in that half region. Okay. All right, now let's go the other direction. This one should be 4. 1, 2, 3, 4. Kind of messy, huh? All the way down. Hopefully when you do this, it's a little bit neater. Okay. All right, now I need to step back for a second, and I need to see where do I have the overlap. The overlap, just like over here, will show me the product. Pretty cool, so let's try. Where's my overlap? Well, I can see that it ended here and it went to 4, so here is my overlapping area. Okay, now let's do the whole numbers first, just because it's easier. I think it's easier to see them. So let's just count. I'm going to count by ones. Very easy, basic way of doing it. I'm going to do it just to make sure that I'm counting properly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I see 12 holes shaded in. So we have at least a product of 12. But I also see that I have these half pieces down below. I can't forget those. That's part of my problem. It's 4 times 3 and a half. Okay, so let's count in the halves. I know that 1/2 plus 1/2 is 1 whole. So I'll count this as 1. Here's another half and another half. Together that equals 1 whole. So 1 plus 1 is 2. I have 2 holes in this area. I'm having kind of a hard time seeing that, so I'm going to write it again outside of my area model. All right, so far I see 12 holes, and I see 2 holes. All together, that gives me 14. So the answer to the problem, 4 times 3 and a half, is 14. Okay, so now we are going to move on and make the problem a little bit harder. Instead of doing a whole number times the decimal, this time let's try to multiply 2 decimals. Sounds scary, but it's not, because we know how to use the area model now, right? Okay, so this next problem is going to be 4 5/10 times 3 5/10. Slightly different than this problem. All right, so at this point, I'm hoping that as soon as you see this problem, you're beginning to think of what the first step's going to be. First step, I'm going to identify the length, 4 1/2, and that will go across the top. Okay, let's count those squares out. 1, 2, 3, 4 1/2, or 5/10. So I need to draw that in because that's a partial piece of this square. Here we go, that looks to be about half. Draw the line all the way down, and let's shade that in. You guys are much neater about shading than I am, so I'm sure your work looks much nicer. Okay, let's hope. Next one, 3 5/10, or 3 1/2. That's going to be my width vertically. 3 5/10. Let's count that out. 1, 2, 3, and here is the half. So try my best to designate half. That looks pretty good. Here we go. Okay, and let's shade that in. Great. Okay, make sure you get all those little bits on the sides because those are the ones that are important here, indicating the halves. All right, now let's check to see where the overlap lies. The overlap, again, is the product, right? So here we go. Across the top, I went 4 1/2, and down the side, the width is 3 1/2. There we go. All right, that's the spot that I should be looking at. Now, just like before, let's count the whole numbers first, just because it's a little bit easier to keep track of. Here we go. 1, 2, 3, 4. This is a half, so I'm going to ignore it for now. 5, 6, 7, 8, 9, 10, 11, 12. Okay, I'm counting 12 holes in this piece. Great. Now let's focus on the halves, because I do know how to deal with halves from my last problem. All right, so here was 1/2. Here is another half. I know that if I add them together, that will give me 1 whole. So let's count this as 1. Can I do that again? Let's look. Here's another half piece. Oh, great, another half piece. Add these together, that will also give me 1 whole. All right, now this is interesting. I see a little piece here, but it doesn't quite look like a half. So I'm gonna ignore that for now. Let's come back to that. Any more halves we can see? Here is 1/2. Here is another half. Add them together, 1 whole. here is 1/2. Ooh, but do I see another half to add it to? I don't see another half to add it to. So it looks like I can no longer create holes with my pieces. So this is going to be 1/2 or 5/10. So let's just mark it as 5/10. Great. Now the only thing I have to worry about is this little piece down here, right? We realize that it's not quite as big as a half. It's certainly not a whole. I need to figure out what that thing is. Well, in order to figure that out, why don't we look at the whole square so we can determine what portion of the whole it is. Here's my whole square. Can you see that? I have a lot of lines happening now. All right, so here is the little piece I'm focused on, okay? And here's the whole square. So I can see that this little piece was created by cutting this in half and cutting this in half. So now my whole has been divided into 4 pieces, right? I can make that into a fraction. I know how to do that. It is 1 in the numerator out of how many total? 4. 4 pieces, 4 in the denominator. Okay, that's great, but we're working with decimals here. So I need to put this in terms of a decimal. An easy way to do that is to think of money, right? So 1/4 of $1, what would that be? A quarter, right? And how much is a quarter worth? 25 cents. So this is actually 25 hundredths. Perfect. So now we've identified this little piece. Let's write that in. Excellent. Now all of my little pieces are accounted for. Okay, so to determine the product, I need to add all of these pieces together to figure the total area. Here we go. So I see 12 holes here. 1, 2, 3 holes here. Now I have 5/10. Just like when we were adding decimals, let's make sure we put our decimal point in the proper spot when we're lining it up. 5/10. And lastly, my little quarter, my 25 hundredths. 25 hundredths. Great. Okay, now it's nicely lined up. I'll put in some zeros as placeholders just to make it even clearer. Okay, and let's add this vertically. So in the hundredths place, I have 0 plus 5, 5. In the tenths, I have a 5 and a 2, that's 7. And then in the ones place, I have a 2 plus a 3, 5 ones. And in the tens place, I have simply a 1. So the total, or the product of 4 and 5/10 times 3 and 5/10 is 15 and 75 hundredths all together. And does that make sense with the second problem, or 4 times 3.5? This number is slightly larger than this number, so I'm guessing that my product should be slightly larger than this product, and is it? 15 and 75 hundredths is slightly larger than 14. So again, good mental check. Nicely done. So I hope that this area model has made it very clear for you. If you still have some questions about multiplying decimals, let's talk about that together and figure that out.